This is the last section of this unit. We're going to be talking about scientific notation. Basically, scientific notation takes really long numbers and makes them short so that it's easier to write. So for example, this huge number, instead of writing all those zeros, you can actually turn it into this, which is much shorter. Or you can take a really long number, even though it's really small, so this is less than 1 actually, it's hard to write because of all those zeros, you can write it like this. So the method for how it works is you first have to turn whatever number you had into a decimal. It can't be 2 digits and it can't start with 0. So for example, this number we had to start, we don't really need the zeros, they're going to go away. We're just going to keep the 1293. So I'm going to write 1293. Then we need to make it a decimal. So we can't make it 12.93 because the biggest we can go is 9. It has to be a single digit to start. We also can't make it 0.123. It has to be bigger than 0. So the first number has to be somewhere between 1 and 9. So we make it 1.293. Now what we have to say is this number isn't actually the same as our original number. We have to multiply it by 10 a bunch of times. Every time you multiply it by 10, the decimal place is going to move over 1. So if I did this, it would actually be 12.93. So we need to multiply by 10 lots of times. And the way we can tell is we can figure out to go from this to this, how many times did the decimal place move? So it originally was right there. That's where our decimal place started. And we can just count how many times over it moved to get to there. So it went 3, 6, 9, 12 spaces over. That means we're going to put a 12 here. Because if we did this times 10, 12 times, it would turn into the original number. Now, the same process works when we're dealing with stuff like this. We're still going to take the number that matters, the 3. We don't need any of these zeros that are connecting to the 0 there because they're all going to basically get multiplied away. So I just need to worry about the actual numbers. So I'm going to write my 3. I'm not going to do 0.3 because like we said, the first number has to be 1 or higher. I'm going to make it 3.0. Then we need to do times 10. And again, we need to count how many times the decimal place moved. So it starts right there, and it needs to move to there. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, so it's not going to be 8. It's going to be negative 9, okay? And the reason we wrote negative is because like we learned when we did negative exponents really means that we're dividing. So it's like 3 times 1 over 10 to the 9, which means we're dividing a lot of times, which makes sense because 3 is a big number and it turns into this little number. So the thing to remember is that when you're dealing with a small number, like 0 point with lots of zeros, it turns into a negative exponent. When you're dealing with a large one, like we did over here, it turns into a positive exponent. That's the basics. Let's look at a couple things here. For our initial numbers, just think to yourselves, are these numbers okay? So could we start with 3.1? So like 3.1 times 10 to the whatever. Could we do times 10 to the 5? This would work. This would be okay. Would this one work? No, it wouldn't. We could change it. We could instead make it 5.0, and that would work fine. Would this be okay? Nope. It would have to be 1.03. We want to keep that 3 because it's still significant. Okay? This one works. This one works too. It's just a negative number. Okay? It would still follow the same rules. We could still do negative 2.5 times 10 to the 5, which means really it's negative 2 that. That's really what it is, actually. That's basically it. The other thing I wanted to mention, when you use your calculator, sometimes it'll give it to you in scientific notation. You just have to be able to read it. So some calculators don't look good and do it this way, where they'll say the number like 5.23, and then they'll just have an exponent written kind of on the side there. Some calculators do it like this green one, where they write times 10 right there and have the exponent. But a lot of calculators I've used is they will have, I couldn't find a picture of it, but they have this E thing. Okay, so your calculator a lot of times will write basically this. It'd be like 9.927 whatever. Then there'll be an E written instead of a number, and then there'll be some kind of number after it. So basically what that means is this is the number being multiplied. This part, this E, basically means times 10 to the power of, and whatever this number is the exponent. So check what kind of calculator you have. And if you put something like this, so like 10 billion squared, or you do to the power of 22 or something, it'll chug it out. When I did it on my cell phone calculator, it ended up looking like this. So you can try it on whatever and just try see what yours is so that you can actually read it and use it properly.